Right now, running an AI workload forces a rigid architectural choice. You either lock your processes entirely on a local machine, or you push everything to a massive monolithic data center. Eric Kolotyluk, a distributed systems engineer with decades of experience, is proposing a different model: AI at home. The proposition is that workloads shouldn't be statically pinned. They should be distributed, coordinating across both edge nodes and the cloud. The current reliance on cloud infrastructure mirrors internal combustion vehicles depending on centralized gas stations. AI at home shifts the topology towards something resembling an electric vehicle. You charge locally when it makes sense, but you maintain the ability to tap into a broader grid. Kolotyluk applies this architecture to a specific high-stakes workload. He is currently self-litigating two complex cases in the BC Supreme Court. He relies on large language models daily to parse thousands of pages of legal documents, a process he calls engineered litigation. But running highly complex, long-term workflows exposes the fragility of current language models. Over time, the outputs degrade. The models hallucinate case law, corrupt ongoing conversational threads, and suffer from persona drift. The industry standard response to these errors is to refine the prompt. But prompt engineering is a semantic request, not a structural guarantee. Asking a model nicely to stop hallucinating fails because it doesn't change the underlying architecture. Achieving reliable, enterprise-grade outputs requires a structural intervention. You have to split the system stack into two completely distinct layers. The first half is the execution layer. This handles purely infrastructure, compute allocation, and routing. It decides where the process runs. The second half is the governance layer. This operates completely independently of the hardware, taking strict responsibility for identity, behavioral rules, and knowledge management. It decides exactly how the agent is allowed to act. By applying rigorous distributed systems principles to AI, you isolate the logic of execution from the logic of behavior. This rigorous structural engineering eliminates standard failure modes entirely, bypassing the constant need for endless prompt tweaking. This diagram shows the AI at home execution layer's three tiers. At the bottom, compute nodes provide processing power, scaling from edge devices to dedicated rigs. The middle layer orchestrates and routes workloads. Everything is unified at the top by a vendor-neutral API. To see the physical reality of a high-end local node, look at this schematic. Kolotyluk details a setup using a TrueNAS HL15 chassis, fitted with a Supermicro board, an AMD EPYC processor, and capacity for 3 H200 GPUs. The architecture routes compute requests based on explicit policy constraints. If a task requires strict data privacy, low latency, or cost control, the system dynamically routes the workload to the environment that satisfies those exact parameters. This establishes a strict architectural boundary. The AI at home stack is purely infrastructure. It dictates where agents execute and how the compute is handled, leaving behavior entirely out of the equation. Mapping the AGET framework onto this model, we place a dedicated layer for identity and governance next to the infrastructure stack. AGET assumes total control, enforcing exact definitions of what agents are, what they know, and their specific behavioral boundaries. This division of responsibilities wasn't coordinated in advance. Kolotyluk independently analyzed the framework and reached the exact same architectural conclusion. Governance requires its own layer. In this decoupled model, the systems are complementary. AGET supplies the semantic rules and operational context, while the local and cloud nodes handle the raw processing capability. Infrastructure alone is blind. Without a dedicated governance layer to constrain and direct the model's logic, the execution layer is just processing power waiting to make mistakes. This matrix maps the most common symptoms to AGET structural enforcement mechanisms. Take hallucinations. AGET forces an assert before verify rule, structurally requiring the agent to verify sources before outputting a claim. The second symptom is thread corruption. AGET enforces temporal fidelity, using structured wake-ups and wind-downs to write state to a version-controlled database, independent of chat history. Third is personality disorder. AGET uses governance intensity locking. The behavioral contract is a locked configuration, so the model structurally cannot drift into non-compliant tones. Fourth is document confusion. The solution is AGET's knowledge architecture, enforcing unique identifiers, version control, and formal ontology definitions, so artifacts occupy distinct directory coordinates. Finally, the information fire hose. AGET implements gate discipline, forcing agents to halt at checkpoints, execute deliverables, and wait for explicit user permission to continue. These 5 precise mappings were not engineered retroactively to match an existing feature list. They emerged convergently from a lawyer logging months of daily, high-stress litigation work, validating the system's design through real-world friction. This matrix demonstrates that unreliability in language models is a solvable problem. It simply requires abandoning the prompt engineering approach and addressing the failures strictly through systems engineering. In a version 4 integration, AGET and AI at home layers merge. First, the AGET agent queries the broker, dispatching the workload to an appropriate edge node. Simultaneously, the node pulls identity constraints from AGET repositories, locking its execution to match the semantic context. This represents a distinct shift toward the individual empowerment pattern in software deployment. Technically capable individuals are taking rigorous command-line interface logic and extending it beyond simple coding tasks into deeply complex, real-world life domains. Engineered litigation requires the exact same degree of precision and context retention as autonomous financial management, healthcare analysis, and complex contract review. The operational pattern remains constant across these disciplines. This architectural confirmation carries weight because it originates from a veteran engineer bringing 3 decades of distributed systems experience to the analysis. The wider artificial intelligence industry consistently attempts to solve behavioral and logic errors by throwing monolithic compute power and larger parameter counts at the problem. The definitive path forward for enterprise-grade reliability requires a structural division. You unite distributed edge infrastructure to handle the compute, and you deploy a strict, structurally enforced governance layer to control the behavior.